Okay, you guys, now that we understand the event loop, it's time to understand this piece of the puzzle in JavaScript. That's called promises. And if you were going to get anything from this lecture is to understand that promises is built on top of callbacks. So whatever we learned is not invalid at all. It's still everything that we have still is based on callbacks and queues and functions. Promises just made things a little bit prettier for us developers, right? So that's the gist of this, right? So I don't know if some of you might not grow up in this era, but when I first wrote JavaScript code way back in the early 2000s, the only time we could do asynchronous is to do callbacks, and it's really difficult to read, right? Because you have a function that has a callback, and then this callback calls another callback, and another callback calls another callback. It's just very hard to read, right? So people invented this promises as an asynchronous way of doing callbacks, but still looks synchronous, right? And it just made it even better with async await. They combined both promises and async await such that it looks way better. It just feels synchronous, but is actually asynchronous. It's going to be clear as we get into examples here. But one thing to note that is promises callbacks are actually scheduled in the process next tick. That now that we know what the process next tick is, this is where promises are scheduled. So just watch out for this. So let's take an example of how promises work behind the scenes. So here's a function that returns a promise. Right? And to return a promise is to basically create a new promise object, and you pass it a callback like this. And the callback will always have two other functions, resolve and reject. What do you want to do when the promise succeeds? What do you want to do when the promise rejects? So it's nothing but callbacks at the end of the day, right? And then this object is immediately returned. So if I'm calling it right here, I call this and I immediately get the promise object. And what is happening is that particular thing is also getting executed at that very time, at that moment. Okay, so it's going to be clear as we go through examples, and I'll show you what exactly is happening behind the scenes. So in this particular case, I'm setting a timeout to simulate a slow promise that will resolve after 4,000 milliseconds. And I am going to resolve it. So I'm going to execute this code after 4 seconds, and then I'm calling resolve. If we call resolve, then the function that is called then, the callback that is scheduled on then, will be executed, which is this guy. Because this X will become just nothing but an object, and then passes, you can give it a function, and that will be called when it's resolved. When it's rejected, you will call the catch, which is not in this example, but it's very similar. And then eventually we're going to call end phase, and then we're going to do a timeout, right? So that's basically how you do promises. And behind the scene, it's nothing but callbacks, really, guys. So that's essentially the trick behind promises. And if you notice the output, what is going to get? Start the initial phase before running, and then immediately before running we get after running, and then 4 seconds later we gonna, well, there's a timer here, we end the phase and we schedule a callback to call the resolved, but nothing will happen, of course, because the promise didn't get resolved yet. And then we're gonna schedule a timer. We finished the initial phase. Now we go to the timer phase. Yes, there's a timer. Now 4 seconds later we execute this processing, and then we just set a variable out, and then we resolve it. By calling resolve, that triggers the second callback, which is scheduled on the next tick, whatever that is in this particular case. And that is we'll call resolved A, and that we get resolved done. So I can technically do the exact same thing using next tick like this. I will do promise work, but I'm going to have it take a callback. And this is my callback, this is my work. And then I'll just schedule whatever the callback, which is the then, if you think about it, into the next tick. And then I give it an output. And here we go. I just implemented promises using the next tick. Pretty straightforward. So how does async await then work? Because if you think about it, promises still gives you this asynchronous version of thing, and it's still hard to read, right? Because you're still using then, right? The idea of then and catch and finally, all these things. So that is why async await is one of powerful concepts that allows you to do exactly the same thing with promises, but gives you the feeling of synchronicity. But behind the scenes, it's still just callbacks, you guys. The only thing we do is, what happens is anything after the await becomes the callback. Anything after the await becomes the callback. Let's take an example. So here's an async function that's called run, and I'm going to execute this as an async await. So I have to mark, as you might know, I have to mark the function as async, and I have to await the function that returns a promise in this particular case. In this particular case, we're not going to get the X is not going to become a promise, but X is going to become the output, the value itself. And as a result, what will really happen is this is the trick that Node will play for us. We're going to call before run. We're going to execute the promise work, which will wait for 4 seconds. And then here's what happened. Anything right after the await becomes the callback. So what does that mean? If I call this, it's as if we executed a function and said, hey, when we're done, call this. And in programming, if you remember, the functions are nothing but go to. It's like, hey, go to this location, right? If I execute a function, all I do is tell the processor to go to this location and it start executing. So that's the game we're playing here. We execute that, and it will go and start executing, and it will just, when it's done, when resolve is called, what will happen is we will call the callback that it's a virtual callback that will take us exactly right here, and it will execute. So what's the output? So what will be the output in this case? I call start running. Let's open the pin. I do a start running. Nothing here. Nothing here. I call end initial phase. Yeah. And then I call run, which is the function, which then executes this before running, which then execute this promise work, which then schedules a callback to that, hey, let's go and do your thing. And then whenever you're done, execute this. So what does that mean? Well, we executed before running. We went here. 4 seconds later, we executed this code, processing, correct? Right? Resolve the output, which is done, which will be returned in the X. Unlike the old example, which we got the promise object here. This is not a value, this is the object that is called the promise, right? Here we're getting the value. That is the promise, the value. This is done. And then here, once I'm getting done, I unblock this. And what do we get then? After running, and then we resolve it. And that's what we get. After running, resolve done. So it gives you the feeling of synchronicity. It's like, hey, So that's basically how async await works behind the scenes. It's just really playing the game of callbacks behind the scene. Everything is a callback, but for the programmer, it's way easier to read, right? Because like, hey, I'm just reading done. When this is done, this was gonna execute. But behind the scenes, there is so complex, right? Stuff happening with promises and stuff like that. So yeah, all of this is implemented in the Node.js and V8. So yeah, promises are implemented are as callbacks. This is very critical to understand. And they run on the next tick. They are asynchronous, and async await makes it look synchronous, but it's still asynchronous. And also it is what? Yes, it's all callbacks. So yeah, let's go through examples where promises and versus callback, and we're gonna actually implement read file as a promise, right? Because read file is not a promise, right? It's just callbacks. So how about we do that? Okay, we're gonna skip an exercise. We're going to exercises 100. Promise. Let's play a little bit. So this is the example that we're running here, initial phase, and we have timeout 4 seconds, and then before, then we execute the promise, we get something back here, and then after running, and then we run this. So let's go ahead and run it. 10, 100. 4 seconds later, we get resolve done. So before running, after running, and initial phase. So let's add some messages. What happens if I do console log X? I'm gonna print X here. Look at this. We get back a promise object. X is being printed here as a promise object. So immediately, we powered through it. It's asynchronous. It's not blocking. So we go through it, run normally, right? And then we play with this X object, and you can, it's just a normal promise object. You can do things with it here. And here, what we really need to do is just chain it. X.then, if X.then, then pass it a function, and that function will be executed when things actually are executed. Otherwise, we do this. So I want to know, I want to show you something here, right? We can add some messages here to show you that before you return, if I do console.log before new promise, you can see that the moment I call promise work, this will be printed, of course, right? And I want you to also know that after new promise, or inside new promise, let's call it. Once I call new promise, I am going to immediately, well, I'm not going to say anything. Let's see, what do you expect the output will be? Start initial phase, before running, before new promise, inside new promise, and then we get the promise object. So this, do you know what this tells us? This tells us that all of this stuff is executed right there. So this function is immediately executed. Immediately. So what happens if I remove the timer? What is the point of the timer? Here's what happens. I remove the timer, and I'm going to run it again just to see. Look what happened. We started the initial phase, before running, before new promise, because before calling the new promise, we immediately got an inside new promise. So that means that at that right there and then we are running that function that is inside the promise. And then we call processing, and the promise is basically done, right? It's marked as done. But guess what? We did not call the then yet, right? We got this and it's a done process. It's ready. And we call after running, and we come here, we schedule this guy, but nothing happens. We go and end the initial phase, and nothing happens. Then we get resolve done. What does that mean? It means that this guy is called on the next tick, because what's after the initial phase and before the timer? You guessed it, it's the next tick. So this is how promises work. It's just they resolve it in the next tick. That's all what it is, right? So let's undo all of this stuff so we don't accidentally check it. Isn't this cool, guys? Once you understand how things work, it's just so beautiful, right? All right, what do we have? Another example here. This is an implementation of promises using next tick. I don't think I can go. I don't think you need to go through this. It's identical. This is basically promises, right? If I run it, yeah, it's identical. After the initial phase, we just run the resolve, right? So the resolved and the reject, for that matter, are always done at the next tick, right? I suppose we can prove that, right? I'm 99% sure the rejects are also the same, right? So let's go ahead and let's do this. Let's do reject in this case, and then do dot catch console dot error, something like that, and then do yep, it's the same thing. It's the same thing. All right. So rejects or resolves are always executed at the next phase. So you can visibly see what the code behind wherever we're writing, right? Without actually opening the source code of Node.js, which is amazing. All right, what do we have? We have promise. This is the async await one. All right, same thing, right? Async await. It's identical. It's just the only difference is we're changing the order of things, right? The callback becomes here, right? It's like an invisible callback that points us right here. Right? It's just weird to reason about, but anything after this code becomes like a whole callback by itself, right? So that's why you have to mark this function as async. Otherwise, the compiler, I guess the interpreter, has no idea how to perform this, right? If I don't do this, the compiler will yell at us. Okay, it's only allowed with async because it needs this scope so that it needs to do this trick such that anything after that becomes a callback. It needs this, right, to run it, right? So that's async await. Similar things. I guess we can run it. Show you. Node 110, 102. Yep. And I'm pretty sure like most people use async await because it's just easier to read, right? And finally, how about we actually implement read file, but as a promised version, right? If before looking at this code, give it a try, right? And essentially, it's really nothing but you call this new function read file promise that returns a promise. Give me the file, and then immediately return a new promise. And then we can move this outside, or we can load it on demand lazily, like we're doing here. So this function will immediately get executed. This will get immediately executed. Now, when I say immediately executed, that means if we're in the initial phase, we're going to open the file. If the file doesn't exist, we're going to schedule a callback, and this callback goes to the poll phase. Just the good old stuff. Promises didn't change anything. Nothing. It's all the same, right? So just like playing with how we essentially, like if the file doesn't exist, we're going to get a reject, and guess what? The reject will be executed in the next tick. So funny enough, if you do promises with read file, it's slower than if you executed directly a read file. And that's because we're delaying the rejects until the next tick. So we're going to call the read file. If the file exists, we just move on and then schedule two things, a read file and the callback that is not ready in the poll phase, right? Same thing. And when we reach the poll phase, the funny part is we're going to issue the read and move on to the next iteration until the read is ready. Then, only then, we're going to execute this callback, which will tell us that, oh, go ahead and resolve this, which will not happen in the poll phase. It will happen in the next tick right after the poll phase, before the check phase. And we're going to resolve that data, right? So if you think about it, promises slightly are slower than calling the functions directly, because there's like, you're delaying it to the next tick versus executing it in the poll phase, right? So it's like slight delay, not much, but a slight delay, right? We're talking like microseconds here, but it's good to understand that, right? If I'm calling this read and I'm doing an await in this particular case, and yeah, just like let's test it. Node 10 103. Look at that. It's just reading the same file name. Yeah. So that's how we do it. If you want to promisify anything, you can do it this way, right? I think there is a library that promisify pretty much anything you want, but it does. That's what it does, right? And it gives you like a promise, and you can chain. The beauty of promises, you can chain them, right? You can say chain a promise to another promise to another promise. It's all right. If I have an array of promises, I want all of them to be ready, and you can delay and delegate, not delay, delegate all these responsibilities to Node.js to check you. Like, hey, I'm gonna execute a bunch of promises, and I want you to check if all of them are ready. Do this. If any of them is ready, do this. So you can do tricks. So promises changed the game, right? It made programming so much smoother as a result, right? All right, guys. So that's all for promises. Let's move to the next lecture.